Hello once again, ladies and gentlemen, and welcome to our virtual classroom. Today we are going to be going over lesson 12-2, which is titled Substitution. And so I do recommend that you pause this video if you've not taken these notes yet, and then just resume the video once you finish copying them down. But let's talk a little bit about substitution. So in mathematics, the word substitution doesn't mean anything fancy. It's actually very similar, if not exactly the same as what substitution would be in any other subject. For example, if there's a substitute teacher, they're simply taking the place of myself, if only for a time, but in some ways they're replacing me for a time. If you go to a restaurant and you want to substitute, let's say that they offer, I don't know, steak with mac and cheese, and that's how they offer it. I don't know what restaurant will do that, but you want to eat something else, maybe a salad instead of mac and cheese, you can ask them to substitute it, or rather replace the mac and cheese with maybe the healthier option on the side. In mathematics, it's very similar. So substitution simply refers to replacing something like a variable with a specific number. So instead of using the variable, you're going to use that specific number. For example, in the formula for the area of a rectangle, we have A, or the area, is equal to the length times the width. However, what if you did know what the length was? What if you took out a ruler and you measured the length of the rectangle and the length was 2 inches, and you measured the width and the width was 3 inches? Well, in that case, you can actually substitute the letter, so the length, for the actual value, the number. So I'm going to substitute, instead of an L, I'm going to put a 2. And instead of a W, I'm going to put a 3. And now I can actually work that out and see that the area is actually equal to 6 square units. Or sorry, inches squared. And so in that same way, ladies and gentlemen, in mathematics, you can substitute, sometimes you can substitute a variable if you know what the numerical value that goes there is. Back into the example that we had with rides going to the carnival, we said that the rides were $3 and per ride. So if you knew the actual number of rides, you wouldn't need to put a variable. You could just put the actual number of rides. Let's say you rode 2 rides, then you do 3 times 2. So I substituted the R with a 2 because that was the actual number of rides that you went on. So that's one way that we use substitution in math. Another way that we use substitution is that we can use it to make an equation true. That is called solving the equation. All right. For example, if I have something like 7 is equal to x plus 5. So some kind of variable x plus 5. Now, an equation, remember, it doesn't just mean the answer. It means an equation can be separated into 2 parts. We have the left side and the right side. And you can think of it as this side has to be the same as this side. Otherwise, it's not an equation. They're not equal. In this case, we're asking, well, what does x have to be for this to be a true statement? If this left side is 7, this right side has to be 7 also. So what does this variable have to be for it to be 7 as well? Well, I can substitute the x with a 2 because 5 plus 2 is 7. So now both sides are exactly the same. Hence, they are equal. And that is exactly what we're going to be doing today, ladies and gentlemen. In fact, let's go to our OneNote notebook. Go to 12-2 and let's look at number 3. Because in number 3, we have something very similar. In fact, it says 4. We have this equation. 4 is equal to 0.5 times z minus 4. Again, we want to see what has to be the value of z so that this side, this right side, will be the same as this left side, which is only 4. Right? So the cool thing about this is that they actually give us different options. We got to choose from one of these numbers. And so let's just pick, let's say I pick the number 8. All right, so instead of z, I'm going to use the number 8. So really, it's going to say 4, that's my left side, is going to be equal to the right side, which now it's going to say 0.5 times 8 minus 4. Actually, let's do like this, minus 4. Now we have multiplication and subtraction, so I'm going to do the multiplication first. So 0.5 times 8, that's actually equal to 4, because 0.5 is half. Half of 8 is 4. So now I have 4 minus 4, and as you can see, 4 minus 4 is equal to 0. Therefore, these sides are not the same. The left side is 4, the right side is 0. So that means that z is not equal to 8, because 8 doesn't give me 4. I'm trying to look at the value of z that would make this whole right side equal to 4. So let's try something new, something different. What if we make z equal to, let's try 16 this time. So 4 is equal to 0.5 times 16 minus 4. All right. So you want to see if 4 is going to be the same as this. So half, or 0.5 times 16 is 8. So this is what I have now. 8 minus 4. And indeed, 8 minus 4 is equal to 4. So I can see that this side is the same as this side, because they both gave me the answer of 4. They are equal to each other. So that means that z has to equal 16. That is my answer. Z is equal to 16. I'm going to cross it out, because the good thing about this exercise is that we're only going to use them once. Let's try number 4. Number 4 is a lot easier in my opinion. We have 11 is equal to x minus 3. So out of these 5 numbers that are left over, which one of them can we substitute for x so that this right side is also 11, just like this left side is 11? Well, I'm going to try 14. I think that one's pretty obvious, because 14 minus 3 is equal to 11. So again, x has to equal 14. Otherwise, this is not going to be an equation. It won't be an equal thing. All right, so again, I'm choosing what value for x. What value for x will make this a true statement? And yes, 14 minus 3 is equal to 11. Both sides are now balanced. They're both equal to 11. Let's try number 5. Number 5, we have 63 over a certain value, or x, is equal to 21. So out of the ones that are missing, which one, 63 divided by which one is going to give me 21? I think 3 is going to work well. So I'm going to do 63 over 3, and that should give me 21. Well, let's go ahead and try it out. 63 divided by 3. 3 goes into 6 twice, and 3 goes into 3 once. So that gives me exactly 21. So 63 divided by 3 is 21. You can see that both sides are now the same. This right side is 21. This left side is 21, but only when x is equal to 3. That's why that is my answer. X has to be equal to 3. Let's try one more easy one. So look at number 6. Number 6 reads, 21 plus a is equal to 29. And again, if I'm going too fast, feel free to pause it, go back to one of those examples and watch it again. But here, number 6. Again, we have this left side. We want to see what value of a is going to make this left side equal to 29, because we want them to be the same. So here I have these numbers to choose from. I think it's pretty obvious that a has to be equal to 8, right? Because 21 plus 8 is equal to 29. Notice I'm working downwards, just like I did when I was doing the box and slice method. Yeah, 29 is equal to 29. So therefore, a has to equal to 8. If you made a equal to any other number other than 8, it would not give you the true statement. Only 21 plus 8 will give you 29. All right. So ladies and gentlemen, that's pretty much how we do today's assignment. But more than that, that's how we use substitution to make an equation true. So I hope you found this helpful, and I will see you soon.